All right, at this point, we're going to go ahead and get started. So thank you all very much for coming. So we're going to do the meeting a little bit in reverse today. So I'm going to talk about announcements first, and then we're going to have Vahid's presentation. So the first thing for announcements is that we are going to be having a competition. So on February 2nd and February 3rd, we're going to be going to Iowa. And so I have a interest form that I would like you all to fill out if you're interested in going to that. The interest form is mandatory. If you do not fill out the form, you will not be considered to go. So please keep that in mind and please fill out the form. It will be due on the Tuesday after break. I will send that out in an email right after this event. Additionally, we will be having, yes, Braden, what's up?
Is it a Google form or like a paper form?
It's a Google form. And then if you guys have any questions, email me, and I will put my email in that. I will put my email in the email so you guys know how to contact me. So the next thing is that we will be, our roundtable event for reminder 6 is the Red Team Tactics, and we will be announcing the time and location of the roundtable event at our next meeting on November 30th. The next thing that we talk about is for Cyber Defense Club, we have decided to create a Slack team outside of the CIS Slack team. And so I will post the link to join that also in the email I'm going to send out. However, please be aware that we are going to be doing most, if not all, of our communication from here on out on that Slack team, or we will be moving towards that in the next week or two.
Yeah. If you're involved in the Saturday Labs, I'm not posting in the current private channel anymore. So if you want updates on the labs especially, come talk to me. I'll send you out an invite independent of that, because I'm not sending out updates via the CIS Slack anymore.
Additionally, in about a week or two, I will announce this ahead of time, but I'm going to actually be removing those Slack channels, so they will no longer exist. So if you want anything that are on those Slack channels, you have about a week or two to get it off. So, and then, what was the other thing? Betsy, what's it? What? Oh yes, there will be a Saturday event this Saturday, and it will be from 9 to noon. If you would like to come join us, please feel free. We will be meeting upstairs in DOE 1117.
Also, if you've been involved with the labs,
All right. Are there any questions on any of those announcements? All right. Thank you all very much. At this point, yes, Braden?
is the vote later tonight voting members only?
Thank you for bringing that up. If you would like to come to the vote tonight, we will be voting on whether or not to host CanSec, as we have to do an official vote to actually get that approved. If you would like to come and are not a voting member, you may I encourage you to come. However, you will not actually be able to vote. So we might have you stand up in a separate area while we have the vote, so that way you don't get confused with the voting members. So, feel free to come to that. Additionally, as a reminder, we will be having another vote after our next meeting on November 30th. So please be aware of that, and please plan on coming to that if you're a voting member. So at this point, any other questions? At this point, I'm going to turn it over to Vahid, who will be presenting on the security of unmanned aerial systems. So please go ahead and give him a round of applause.
The supervision of thanks. Under the supervision of Dr. Arsalan Munir, I'm currently working on security and vulnerabilities of complex adaptive systems and artificial intelligence, especially deep reinforcement learning, the thing that AlphaGo and things like that were based on. Before that, I was at the University of Nevada in Reno working on the security of UAVs and UAS. Traffic analysis in networks, especially covert networks like Tor and such. I worked on topological security and a bit on counterterrorism. And before that, I was at the University of Birmingham in England, working on reconfigurable antennas and radio front ends, mostly for cognitive radio applications and millimeter wave applications. With regards to UAV security, aside from the research that I've done at UNR, I've also consulted, been an external consultant for a number of defense companies, mostly startups, on anti-drone technologies, which we'll talk about towards the end of this presentation. So, unmanned aerial vehicles, UAVs, drones, what do we know about them? We have definitely heard the term in the news, especially in the context of its military applications. UAVs have been heavily applied in high-value targeting operations in Iraq, Afghanistan, Somalia, Yemen, and places like that. But what other uses of UAVs have you heard of? If you follow the tech news, UAVs are thought of as a good alternative for delivery mechanisms. Amazon is thinking of using drones to deliver packages. There are a couple of medical or healthcare companies that are thinking of using drones as means for delivering medicine to remote areas, especially in Africa and places like that. In homeland security, drones are being used by law enforcement for ISR applications. Does anyone know what ISR stands for? Yep.
Intelligence, surveillance, reconnaissance?
Exactly. ISR stands for Intelligence, Surveillance, and Reconnaissance. So what does that mean? It means that drones, UAVs, can be used to gather intelligence, do surveillance, and reconnaissance on areas which require a bird's eye view or can benefit from a bird's eye view. Other than that, it's being used for border security and border patrol. It's being used heavily by the Coast Guard and even for rescue, small-scale rescue operations. Someone was telling me that one of their relatives was saved at some beach in California, I believe, after a drone noticed that she was drowning, which is a relatively cool application of drones. Firefighting operations. So you've probably seen the footage of traditional planes being used for firefighting operations. They go above a wildfire somewhere and they release a relatively large amount of water over the area that's caught fire. What's the problem with that approach? Well, first, it's relatively expensive, and also for a pilot, taking off with that amount of water is very risky. There have been many incidents, well, actually, accidents happening during takeoff where pilots have lost their lives, and even other flight crew on the ground have lost their lives because the airplane is very heavy and the weight is fluid. So takeoff is really dangerous, and it would greatly benefit firefighting operations if that risk was not involved in an already risky situation, right? Other applications, the energy sector is using it for monitoring and, well, essentially finding out which areas have power, don't have power, and things like that. In agriculture, our university is very active in using drones for precision agriculture and monitoring crops and fields using UAVs, mostly quadcopters and small-scale UAVs. Remote sensing is a similar application, and communications and broadcasting is a relatively emerging applications of the UAVs. So assume that you're in a disaster area. Assume that you were in Texas when the hurricane hit. Most base stations and regular communication systems were down during the first few hours of the hurricane. In those circumstances, the firefighters can simply use or deploy UAVs to act as temporary base stations or communication relays. And this idea has been heavily used in battlefields, especially during the 2001 operation, 2003 operation in Iraq, UAVs were heavily used as communication relays for the troops on the ground. So, the title of this presentation is Security of Unmanned Aerial Systems. How is an unmanned aerial system different from an unmanned aerial vehicle? Well, an unmanned aerial vehicle, a UAV, is just a vehicle, but that vehicle on its own cannot be as useful as it can be if it's combined with other utilities. For example, if you want to fly a drone in an area that falls out of your line of sight, you definitely need a way to keep track of the position of the UAV. We all know that GPS is available to us. GPS is one instance of GNSS, which stands for Global Navigation Satellite Systems. The GNSS system becomes part of an unmanned aerial system which supports a UAV's operation. Most UAVs these days are remote controlled, so not many UAV operations are autonomous yet. When we say that they are remote controlled, it means that there needs to be some ground control station for the UAV. There's got to be a pilot on the ground that's controlling the actions of the UAV. So that ground control station becomes part of a UAS. There are satellite relays for long-range, mostly military UAVs, so Predators and RQ-170s and all that you see in the news being deployed for military applications. They need satellite relays, otherwise communications and control of those drones would be impossible. There are sometimes multiple drones working on the same operations. These multi-UAV operations require communication links between drones themselves, so the additional drones become other parts of a UAS, or unmanned aerial system. Now that we know what UAVs and UAS are, let's look at some historical events in compromising the security of UAVs and UAS. One of the most notable ones happened in 2009 when JSOC, Joint Special Operations Command, performed an operation to capture a number of militants at a safe house somewhere around Baghdad, I believe. If you don't know, it's conventional for JSOC to perform its operations, especially capture operations, after a long period of surveillance. And back then in 2009, drones were already heavily deployed for surveillance applications. Remember, ISR, S stands for surveillance. It turned out that after the capture, after they performed the operation and gathered some intelligence from that place, they found out that these militants had recorded live video feeds from the drones that were performing surveillance over their safe house. How is that possible? What kind of technology is required to capture a drone's feed? A $25 DVB card. That's how ridiculous the whole situation was. In 2009, more than 70% of the ISR drones deployed by the US military did not use encryption in their live video feeds. That's scary, isn't it? All right, let's move on. In 2011, the security staff at Creech Air Force Base in Nevada found out that one of the control computers was infected with a keylogger. Does anyone know what Creech Air Force Base is known for? Yeah, please go ahead. Exactly. Creech Air Force Base is where those containers, those boxes are placed in which the UAV pilots operate remote UAVs in the Middle East, in Africa, and other places. So a keylogger and a virus infection in one of those computers is a huge breach of security in military ops. How did that happen? Well, the details are still classified, but the general assumption is we know that this Air Force operates an air gap network for their drone management computers, and the gap was breached in the same way the centrifuge control systems were breached in Iran during the Stuxnet operation. Does anyone know how that breach happened?
Someone found a USB and plugged it in.
Not as silly as that, but you're close. Yeah?
Infect a computer that hops between the two.
Exactly, yes. So an engineer who used to consult for the control system management, the industrial control systems at that enrichment facility, that consultant was working on other projects as well, and he brought his personal laptop to work one day and used his USB stick to copy a piece of software from his laptop to one of the control computers. Before that, Stuxnet was just a regular harmless propagating virus. It infected one computer and any other computer connected to it. And that's how the infection got into an air-gapped network. We assume that the same type of breach happened in the Creech Air Force Base scenario. Let's move on. This is probably the most high-profile attack. Yes?
Quick question about Stuxnet. That was designed to look for PLCs, right?
Exactly, yes.
So is it known whether the Air Force Base...
As far as I know, I don't have access to classified information. The keylogger was a generic keylogger designed to act on BSD operating systems. So no, it wasn't targeted, but it did the job. If the question is whether the attack was targeted or not, I assume based on the information that's publicly available that yes, the attack was indeed targeted.
Oh, I just mean, is it known whether it's inert or generic?
The keylogger, as far as I know, was generic. But getting it into Creech Air Force Base requires a targeted operation.
So it hasn't spread in the wild?
No, not as far as I know. Now, let's talk about this incident here. Towards the end of 2011, when you opened any news website or news channel, you kept hearing about Iran capturing a U.S. military drone over its soil. Does anyone know how this kind of attack is possible? Any guesses? Any ideas? We'll learn about how to do this type of attack towards the end of this presentation. It was actually pretty sophisticated, but very basic in principle. All right, so what are the attack surfaces in a UAV? Before answering that, we need to know what a UAV is made of. This is a typical quadcopter, and the major components in a quadcopter, in a commercial quadcopter, are very similar to the major components in military drones. What are these major components? There's a flight controller in the middle, which is essentially a processor loaded with scripts and programs that run that control the actions of motors, rotors, and other avionics. There are sensors on board. You can see the sensor block down. If you can see it, there's a sensor block here. In most modern commercial and military UAVs, the sensor block is a bit larger than this, but the task of the sensor block is to analyze and process the sensor information and control the sensors on board the UAV. There's definitely some type of radio interface which is used to establish connection with the controller on the ground, and there's usually a GPS unit for telemetry using GNSS, Global Navigation Satellite Systems. And there are controllers for the motors on board. So this is very mechanical. Let's get into the network aspects of it. Networking in UAS is almost always of the wireless type. So it means that we have to look into the type of wireless interfaces that may be available on a commercial or military drone. And these are essentially all possible types of links that can exist on a UAV. Well, the first one is GNSS, like GPS, combined with inertial measurement unit. These two sensors can guide the navigation and telemetry of a UAV either autonomously or for a remote operator. Does anyone know how an IMU works? Odometry? Yes?
It adjusts for the error in the GPS by taking into account the physics at play on the GPS in the intermediate.
Exactly, but let's go into more details. Let's say that I'm blind. I know that I always start my movement from this table here. I want to get to the door. I know that the door, when I start my movement, is to my left, is 10 steps to my left. What an IMU does is essentially it tracks my movements compared to the point of origin. For example, if I turn left, the IMU keeps track of my orientation. And then I take 5 steps, and then the IMU tracks my position by knowing that I'm 5 steps to the left of the original position. That's how IMU navigation works. The other word for it, if you want to go into robotics and follow up on this idea, is odometry, O-D-O-metry. What other interfaces are available? SATCOM for satellite navigation, for satellite relays. Who can tell me what IFF stands for?
Identification friend or foe.
Exactly, yes. IFF stands for Identification of Friend or Foe. If you're in a battlefield, you need to know whether an approaching object or a communicating object is friendly or enemy. And IFF protocols do exactly that. What else? Multiband datalink antenna. As you can see, it's usually towards the ground, so it communicates with a ground station or a ground relay. Ultra-high frequency band antenna, usually used for video relays. Radar antenna. Radar antenna is essentially for active perception of what's going on in the environment. It's a radar, it's a typical radar. It tries to find out whether there are other objects in the environment and so on. And optical and IR sensors, it's pretty self-explanatory. Any questions so far? Okay. Now, let's get into the interesting bits. What are the attack surfaces in a UAV? I decided to title this slide Cyber Physical Attack Surfaces. What differentiates cyber physical attack surfaces and traditional attack surfaces that you guys have been looking into, especially in the areas of network security and software security? Cyber physical attack surfaces are attack surfaces that either exist because of the cyber physical connection or relationships between an information processing unit and an actuator in the real world, or the attack vector itself is cyber physical. Changes in the physical environment or the mechanical environment causes a malfunction or manipulation of operations in the cyber domain. So we aren't going to talk about software vulnerabilities today, not specifically. What are the cyber physical attack surfaces? Well, here's a good list. Sensors, navigation system, air traffic control, fault handling, physical layer in the networking system, link layer, network layer, and in my opinion, the most interesting one of all, the artificial intelligence that's being implemented in autonomous or semi-autonomous UAVs. We'll be talking about all of these categories in the following slides. And why not the application layer? Well, the applications on board UAVs, from the operating system to the software that controls the communications and flight, are usually too diverse. And attacking the software on board a UAV is usually too easy. We don't want to talk about easy stuff. Just to show you how easy it is, I want to show you a quick demo of one of the projects that I worked on back in UNR. I'm going to allow this on my computer. All right, so what you see here is a feed from a Parrot AR drone. It's an element in a 3-drone multi-UAV system. So what I'm doing here is, first I'm looking for a network. I'm trying to detect communications emerging from this type of UAVs. We know that it happens at 2.4 ISM and the protocol is 802.11, it's Wi-Fi. Once that happens, we enumerate the target and then we try to spoof ourselves. The attacker tries to spoof itself as a node within that network. And then it uses a very simple busy box exploit to get access on the UAV. And then from here on, we use a compromised UAV to perform an attack on other UAVs. All right. So how long do you think it took me to implement this attack? From the moment I got the drones, I got my testbed equipment. Just a wild guess.
An hour.
That's too wild.
How many days?
Days? Any other guesses? Well, essentially, yes, it took me 4 hours. 4 hours to implement an attack on a very popular civilian drone. All I needed was a Wi-Fi card that can go into monitor mode. The rest was a Wi-Fi attack and known exploits. We don't want to talk about these easy stuff. We want to go into hardcore drone attacks. So let's start from sensors. We know that UAVs are data-driven systems. They're remotely operated systems. So for them to be correctly piloted, the sensors become the eyes and ears of the pilot. And the pilot can be a human operator or it can be an autonomous autopilot system. Some instances or examples of sensors on board the UAV are visual navigation sensors. So sometimes vision-based inputs can be used to calibrate navigation and target detection. When I say target detection, I'm using the terminology used in missile engineering. Many guided missiles, especially laser-guided missiles, use visual cameras. They use RGB cameras to follow up on a visual input, which is a laser beam. PTOT and altimeter and sonar sensors and such. So what are the attacks that we can launch on these sensors? Well, we can spoof the input signal. We can exploit the limitations of sensors through manipulation of visual inputs. For example, in the case of a laser-guided missile, what happens if there are 2 or more laser beams on the same frequency and with the same characteristics as the targeting laser? What's going to happen then? manipulation of the electromagnetic dynamics of the sensor. Let's assume that we can somehow direct an electromagnetic pulse towards an electronic sensor. That sensor may be overloaded or may be manipulated then. Manipulation of auditory and physical inputs. Auditory definitely works on sonar, so what happens if you add sources of audio which would mess with the sonar readings? Or physical manipulation, what happens if you intentionally change the air pressure around a UAV? That would affect the PTOT. PTOT, for those of you who are into avionics, is essentially a pressure meter, a pressure sensor. And if you change the readings of the pressure, the altimeter malfunctions. So the drone or an aircraft would have an incorrect reading of how high or low the aircraft is flying. These are the spoofing attacks. What about jamming attacks? Jamming is very simple. You can just saturate the CCD behind a visual sensor, for example, using a laser beam. Or you can do EM disruptions using electromagnetic pulses and so on. Navigation. So navigation in modern UAVs is mostly dependent on GNSS signals, like GPS. So GPS is a passive sensor. It's a passive sensor. It's not active. So a GPS reader or a GPS receiver does not ask for its position from the satellites in the sky above. What it does is it receives signals from 5 or 6 different GPS satellites in orbit. They are mostly geostationary satellites. It means that their position is usually known. And based on the difference between the reception time of the signals from those satellites, the position is estimated. The position of the receiver is estimated. So what can be done here? Well, jamming is definitely a good solution, is a good attack vector. If you overpower the signal that's coming on the GPS bands, the receiver is not going to receive anything. How does jamming work? A quick, simple example is assume that you are in a party, which is very loud. Everyone is talking. And you want to communicate with your friend. You want to talk to your friend. You start shouting and telling him, hey, Joe, listen to me. And at the same time, someone else nearby shouts with a louder volume. And Joe, your friend, essentially hears a garbled message, doesn't understand what you're trying to communicate, or hears the voice of the louder person first. The first case, when the message is garbled, is jamming. The second case, when the receiver decides to hear the higher volume, the higher amplitude, is spoofing. So a ground station can essentially transmit a higher power signal in the same band as these satellites and make the receiver believe that the signal coming from this base station is a GPS signal. And using this spoofing technique, the GPS estimation of the receiver's location will either be corrupted or manipulated. These type of attacks have been heavily used or at least demonstrated in the UAV domain, and they are relatively cheap and easy to implement. For those of you who are into radios and software-defined radios, there are open source toolkits for implementing GPS spoofing attacks. But, legal disclaimer, don't do it, it's illegal. You can go to jail. Air traffic control. Soon, or maybe in a couple of decades, UAVs will be very pervasive. They will be used for delivery, they will be used for monitoring and so on. So there may be multiple UAVs operating in the same airspace. Those UAVs must have a way of avoiding collisions or near-miss situations, which is very similar to the problem of air traffic management in commercial and military aerospaces. One of the solutions that can be used for autonomous UAVs or commercial UAVs is the use of secondary surveillance traffic monitoring. How do these systems work? Well, let's talk about a well-known example, ADSB, Automatic Dependent Broadcast Surveillance. ADSB is currently implemented in more than 80% of commercial aircraft in the US, more than 90% in the continental Europe. How does this protocol work? Every aircraft at 1-minute intervals broadcasts its position in terms of GPS coordinates and altitude, as well as its heading and velocity. How does this broadcast happen? I think you guessed it, in plain text. Is there any way to authenticate the source of an ADSB message? No. So right here, right now, if you have the right equipment, which right now costs less than $500, we can broadcast our position as that of an aircraft, or we can spoof an aircraft in the Manhattan airspace. And it's very simple to do. So, well, spoofing aircraft in an airspace is dangerous, but the really dangerous part is when these sort of systems and protocols are the basis for autonomous and automatic traffic collision avoidance systems. So most commercial aircraft in the US today are also equipped with TCAS, which is a protocol that uses ADSB readings to predict collisions and then provide advisories to change course and avoid collisions, to prevent collisions. How do they work? Well, they predict collision in 10 or less minutes ahead based on the current trajectories of UAVs or other aircraft around, and then the current version of TCAS only says go up or down. It doesn't provide more dimensions in its advisories. It doesn't say, well, you can yaw right or yaw left and so on. So what happens here is, if you can spoof, yeah?
Sorry, real quick. Would you need multiple sets of the hardware to spoof multiple aircraft?
No, you don't.
Okay, you just need one set to spoof multiple?
Yes.
Okay,
It's as easy as that.
that's great.
Not really. Okay, yes?
What's the range on the ADSB for aircraft?
It's supposed to work for 100 nautical miles. I believe in practice, airworthiness of ADSB units is granted even if they cover around 75 nautical miles.
But in terms of spoofing, it's however big of a transmitter you can get to transmit the signal.
Exactly. Yes. Okay, so let's look at an example of how we can induce collisions by exploiting collision avoidance. Note, there has been no publications on this so far. No one has looked at this kind of vulnerability yet, as far as I know. And the only mention of this type of attack so far has been in my 2015 paper. So if anyone is interested in following up on this as a term project or a master's project or a research project in general, I highly encourage you to come and talk to me after the class. How does this attack work? Well, let's say that, where's the pointer? We strategically spoof two UAVs or two aircraft in these two positions such that UAV 1 and UAV 4 detect them as possible collisions in the near future. So what's going to happen here is TCAS is going to tell this UAV to climb up, and TCAS is going to tell this UAV to climb down. Now, as soon as they do this, if they are at a certain or below a certain threshold in altitude separation, they will no longer have time to correct their path and they will collide. The attack is as simple as this. Any questions so far? Yes?
I mean, the odds of those 4 aircraft being in an exact position.
That's why we spoof the additional 2 aircraft.
Sorry.
All right, yep. Question? Yeah?
So with this, if you're spoofing 2 aircraft, would that not require the 2 other aircraft to be on exact opposite headings?
Yes. Yes, it does.
Uh,
If they're moving with parallel vectors, as in they have the same heading, one way to cause collision is to spoof these 2 airframes instead of these 2.
Or if you were looking at their vector straight down, if they cross at all, there's technically a point for collision because you have control over their altitudes via the spoofing.
Yes, exactly. Thank you. Other questions?
You just make the aircraft crash instead of like.
Yes, but not with this type of attack. We'll talk about it. Yes?
So if this is completely unauthenticated, is it also untraceable?
In the realm of radio attacks, tracing is not as simple as you'd think. So if you want to track or trace the source of a radio signal, one thing that you can do is to deploy a car or a vehicle with a rotating directional antenna trying to estimate the direction of arrival of a signal. And then when you get the direction, move to that direction and try to follow up until the signal gets stronger. Can you imagine how long it will take for FAA to track a 100 milliwatt signal coming from my home in Manhattan? Just a wild guess. Exactly. But how long does it take? A while. That's a correct answer. So something interesting happened. 3 weeks ago, I was traveling, and when I came back, I saw that there was a notice on my door, on my apartment's door, from Cox Communications. I use Cox at home. And the notice said, there is some signal spillage from your receiver. We have to come in and see what the source of the signal spillage is. And I'm not operating any offensive radios at home. I'm a good citizen. So what happened is the next day, someone from Cox came to my place and told me there's a signal spillage in the aeronautical band, which is a little scary. And he had one of these directional antennas tuned, whose crystal was tuned to that specific frequency, and he followed up on it, and we found out that one of the coax connections in my, I think it was in my bedroom, was loose, and the spillage was causing interference on the aeronautical band. I asked him how long it took them to track the signal, and the guy told me around a week. It is very disturbing.
The fact that a loose connector can have enough it can produce enough signal interference that it will be noticed.
Yes, exactly. So for those of you who are not familiar with the basics of wireless comms and radio engineering, the signals that we usually deal with at the receiver side are usually less than 1 milliwatts. Usually use less than 1 milliwatts of power. For GPS, I believe it's in the microwatts level. It's not that much. And a little bit of interference can actually interfere with the signal. Communication engineers use sophisticated techniques, signal processing and filtering and such, to recover signals at those low power levels and in the presence of interference. Yes?
Do you happen to recall what the frequency was?
For,
The spillage.
I think it was, I don't remember. I'll look it up. I took a note of it.
VHF then?
I think it was VHF. Actually, no, it was UHF. It was UHF. I think it was 900 something megahertz for mode S, if you know what mode S is. So
That's almost telepathy.
that's almost what?
Cordless. That's almost cordless.
Yeah.
So
So we are still talking about, well, I think cordless is in a different band, but it's still in 900.
Right.
It's another ISM band. But this one specifically is not ISM. You require a license. That band that they were tracking is not ISM. Is not license free. You need to obtain a license to operate in those bands.
if it's mode S, was it interfering with transponder signals?
Yes.
Was it like corrupting the signals?
I don't know. I didn't dare to ask.
So did Cox have a license to broadcast in that?
They don't, no. But they are mandated to prevent their equipment from a spillage.
Because they were broadcasting in that.
Yeah. So, well, it wasn't my problem, so I didn't want to get into it at that time. But essentially, Cox will be legally responsible for any spillage happening because of their equipment malfunction.
This is shielded coax.
Well, coax is intrinsically shielded. Coax is coaxial. There's an outer electromagnetic surface, then there's an inner electromagnetic surface, and then in between the guided wave propagates. So at the connector level, there is a way for signals to go out, and there are actually antenna designs based on this spillage. There are guided wave antenna designs that use this idea to intentionally transmit waves. Anyways, shall we move on from this topic? Fault handling. So, faults are usually inevitable in complex systems. And for mission-critical applications, the engineers have to come up with fault handling mechanisms. Like, how would you, as a designer, try to handle the case when the communication link between a UAV controller and the UAV itself is broken? Any ideas other than these?
Is the UAV armed? No, I'm serious.
Assume that it is. Now, do you have any specific ideas related to armed UAVs? Return to base is one solution. What else?
So find a non-populated area and nose dive into it.
Okay. That's a very good solution, which is actually being employed in military UAVs that are armed.
What was the solution?
Find an unpopulated remote area and self-destruct.
Would another option be try to land itself if they can find a open area?
Yeah, that would work for civilian UAVs, but military UAVs are high-tech, privileged systems. They don't want the enemy to get their hands on the technology.
It's like jerry-rig the collision detection. So like if someone does come close and does disarm it, like boom, like two birds, one stone.
Yeah, that's a self-destruct option. That's a self-destruct option. I've never heard of that specific methodology being applied, but we can look at it as an attack vector.
Cloud of debris in front of another aircraft is just no longer controllable. Once it's a cloud.
All right, so let's talk about the four most popular fail-safe handling mechanisms. One of them is to hover until the connection is reestablished. If it's a quadcopter, it's relatively easy. If it's a fixed-wing aircraft, it's going to, well, go into a hovering pattern which encircles an area. What's wrong with this option? If it's operating in hostile territory, going into hover mode is going to make it easier for the adversary to implement kinetic attacks. Use a missile, use I don't know, bullets or whatever other means to capture the aircraft because, well, it's now running in a known trajectory or predictable trajectory. What else? Return to base. What's wrong with return to base? When it's combined with navigation attacks, return to base may actually mean return to enemy's position. If the enemy can spoof the GPS signal and make the UAV think that home is where the enemy lies, then the UAV will land in enemy's land. This is how most of us in the unclassified universe assume the Iranians captured the RQ-170 back in 2011. GPS spoofing combined with jamming of the control signal and invoking the RTB, return to base failsafe mechanism. How much does it cost equipment-wise to do this? Any guesses? Less than $1,000 with an SDR, software-defined radio. Land. Well, if it lands, it can be captured. Self-destruct. If we can manipulate the sensors on a UAV to simulate capture or attack conditions, then we can make it to self-destruct on our own command and will. So self-destruction can actually become adversary's goal instead of the operator's fail-safe mechanism. The physical layer in the networking side of things, well, many UAVs need to have multiband or adaptive radios, some of which are very close to software-defined radios. They do a spectrum sensing to find empty bands or empty bits of the spectrum that they can transmit on. And the same type of attacks that apply to cognitive radios and agile or adaptive radios can be applied here. If you can manipulate the sensory readings of the adaptive radio on board the UAV, you can manipulate the parameters that it basically derives from those readings. Manipulation of anti-jamming solutions. So back in 2015 and in 2016, I was working on physical layer anti-jamming solutions for mobile nodes, specifically and in particular UAVs. And one of the solutions that we came up with and we proposed was using beam nulling. So instead of using a directional antenna, most antennas have an omnidirectional pattern, as in they receive anything that comes. They do not discriminate. Some antennas are directional. If you recall the old school Yagi antennas with all those spikes coming out of it and a single line, those are highly directional antennas, but they are not applicable in mobile conditions. Beam forming and beam nulling using array antennas is one solution, and if you can detect the direction of arrival of a jamming signal, you can just null that direction and basically filter out the jamming signal and retain communication with other nodes that are not in that direction. So this was the solution that we proposed, and now I'm going to tell you how we can beat that solution or exploit that solution. The solution can be exploited by either spoofing or actually strategically injecting jammers in the aerospace such that all or most of other nodes that the antenna needs to communicate with fall under the nulling criteria. This is essentially a smart jamming solution. Is it clear?
You have to get them physically close enough.
Not physically. Well, if it's spoofed, it doesn't need to be physically. If it's not spoofed, if it's actual, they don't have to be close enough. Assume that there is a UAV here, another UAV here, and now if you position a jammer here, transmitting a jamming signal to this UAV here, the beam nulling algorithm of this signal is going to null this direction, and right in this direction or in this angular space is another UAV that this UAV needs to communicate with, right? So now this UAV cannot communicate with this UAV. If you strategically place these jamming sources, you can essentially induce a self-jamming scenario.
Yeah, but that's no worse than being jammed in the first place, is it? Because with those jam sources there, like, even if the beam null didn't happen, they would still be jammed, right?
That direction would be filtered out.
Without beam null.
Without beam nulling, yes. Yes, that would be jammed. But now here you don't really have to do jamming. You don't have to spend power in actual jamming. You don't have to transmit a 2 kilowatt signal at every second. All you have to do is to fool that system and its predictive dynamics that, hey, I'm here, I'm jamming you, I'm bad, filter me out. And that mechanism can be exploited to filter every other node in the network out. Again, there is no publication on this, and if you're interested in working on this, come and talk to me after the lecture. Yes?
Are you saying that the attacker has to get, does not have to get the jammers closer?
No.
So there's no system of dead reckoning?
What do you mean?
Is there a way to objectively assess distance?
There is, but not very accurate, especially in the cases of smart jammers who try to be adaptive and unpredictable. We can talk about it later. I'm slightly running out of time. That's very correct.
I did some research on this way back.
Right. Well, the state of the art is not that much different from how it was 20 years ago. It's actually still at the same level as it was when the first manual on electronic warfare was written for the US Army. But we can talk about it more. In anti-jamming solutions, the key word is, I don't want to say mitigation, but reducing the effect and impact. And then a regular UAV implements its antennas in different orientations with respect to its intended receiver. Now let's assume that there is a multi-band data link antenna right under the belly of this UAV. This is actually a Predator, I believe. This model is based on Predator, if I'm not mistaken. Predator is a US military ISR and combat UAV. And this multi-band data link, the antenna for this multi-band data link, is pointed directly downwards. Now what happens when this UAV is climbing at a steep angle? This antenna no longer has a line of sight or any kind of coverage with the receiving antenna, and the communication is disconnected, and the link is disconnected. So if we can somehow manipulate the trajectory of a UAV to do frequent steep climbs, we essentially induce self-jamming mechanisms. So if we continuously invoke a TCAS attack and make the UAV climb continuously at with a high angle, what's going to happen is the antenna under the belly of the UAV is not going to be able to communicate with the antenna on the ground station.
That assumes that the antenna isn't making adjustments for that.
Exactly. So one solution for this is to use either pattern reconfigurable antennas or physically, mechanically adaptive antennas.
So you just need like a rotational degree of freedom?
In both dimensions, in theta and omega. But the complexity of these solutions kind of make them unfeasible for implementation in military vehicles.
Really, I mean, for anything pointing down, you can exploit gravity.
Exactly.
So you're saying the complexity makes it infeasible. How complex is it really?
The attack itself is not complex. The defense,
Defense of pointing the antenna down.
Not all.
you can't just attach a weight to the antenna and say, hey, always point to the center of our planet Earth. What you have to do is to adjust it such that, first of all, it doesn't interfere with the other antennas. There's always a spatial isolation between that antenna and its direction of propagation with other antennas.
You could do that in terms of pausing transmissions when it's going to interfere.
And that would be an overhead which is highly undesirable, especially when it comes to live operation and ISR feeds.
The alternative is loss of communication, which means that you're still better off.
Exactly, and in that case, I highly suggest that you get in touch with DoD and DARPA and tell them, hey, you guys are absolute idiots. You can do this, but since that additional system is another piece of a complex machinery, the additional complexity of that system by those who work in aircraft verification and such may be undesirable because we don't know what other vulnerabilities may emerge from the interaction of this component and other components in the system. It's a viable solution. I agree with you. I still think that it should be implemented, but it's not. And I don't think it's because the US military or other militaries in the world don't know that this solution exists. All right. Link layer and network layer. Traffic analysis. Who can tell me what traffic analysis is? Other than Eugene. Who can? You were pointing at a very wide angle. Can't really.
It's when you listen to the traffic and you see it, you take a look, analyze it, see what it contains.
Kinda, yeah. That is content analysis, but the traffic analysis I want to talk about here is mostly finding out who's talking to who. So the whole point of Tor, the onion router, and those privacy schemes is to prevent the authentication and detection and tracing of who's the source and who's the sink. You have a question? Now, back in 2015, I did my master's thesis on finding out the topology, the sources, the sinks, and the general network topology of covert tactical ad hoc networks. My solution is only based on transmission timings. I assume that all communication is going to be encrypted. I assume that we have no knowledge of the protocol being used. We don't know anything other than the fact that the nodes in this network communicate in a multi-hop fashion. For example, if node 1 wants to talk to node 6, it has to relay its signal through nodes 4 and 3. This is multi-hop communications. This is what multi-hop communications mean. And what I did was I proposed a relatively simple metric and a statistical modeling approach for learning the topology of a covert tactical encrypted ad hoc network based on the timings of each transmission. So when did node 1 transmit a signal? Let's say it's at T0. When did node 4 transmit a signal? Let's say it's at T0 plus delta, and so on. We know that if node 4 is a relay for node 1, it usually transmits at the time very close to the transmission time of node 1. Yes?
What do you mean by covert, what you just said? Covert tactical. Covert in what manner?
So there are two aspects of covertness that we consider there. One of them is they're trying to conceal that there are transmissions in general by using wideband transmissions and such. The other was they've concealed all information about their communication protocols and the contents of each transmission. All right?
There's one paper you definitely want to look at, and that's the exact title is How Much Information Does a Network Need?
Yeah, I've glimpsed over that paper and it's very interesting. The experiments and simulations that I essentially did to confirm or verify this proposal were on 802.11 Zigbee and a proprietary tactical protocol. The simulations,
That was at the upper layers, just doesn't apply.
it still kind of applies.
The results
I don't remember the results. Can you remind me?
The analysis doesn't apply, but the results apply. Tor leaks 9 bits of IP information per hour or so.
They didn't, if I recall correctly, they did an entropy-based analysis. Am I right?
So roughly 9 bits.
And I remember widely disagreeing with their analysis, but yeah. We can talk about this offline, after the talk. In general, for wireless transmissions, especially tactical communications, since the transmissions have to be frequent and are mission critical, it is possible to perform traffic analysis attacks and come up with some estimation of the topology of the networks. When we have the topology, then we can find critical nodes in the topology whose disconnection would disconnect the entire network. And unfortunately, we don't have time to go into the details of this. Bill, do you have a question?
Yeah, just a quick clarification. When you say wideband, you mean like
Spread the spectrum. So one of the techniques for establishing covert wireless or radio communications is to spread the signal over a wide band and then at the same time lowering the power in each of the sub-bands that you are doing this. And then you can do, you can apply different coding schemes over there to make it more resilient or resistant to discovery. Bluetooth uses a similar scheme, if I recall correctly.
Frequency hopping, but not wideband.
Is it not? Yeah, it's FHSS, but yeah, it's frequency hopping. I'm going to trust you on this. I don't remember the specs of Bluetooth, but yeah.
653 sub-channels into the 11
Yeah.
sub-channels of Wi-Fi.
So yeah, it's not wideband. All right, moving on from this, you can apply topological attack, finding out nodes whose removal would disconnect the network completely. So instead of jamming every node, you can jam certain nodes, a minimum cut set or a minimum number of nodes whose disconnection would cause maximal disconnectivity in the network. Routing attacks are very similar to routing attacks in ad hoc wireless networks. You can implement black holes who receive traffic but don't relate or transmit it or forward it and such. Now, my favorite topic, artificial intelligence. How can we exploit the AI aspects of autonomous UAVs? Any ideas, any guesses? I just want to see if you guys have looked into AI security at all. You have to. Not because it's an emerging threat, but because it's nirvana when you read all about the exploits that are being implemented on AI. Yep?
So, are we talking about like AI attacks on drones?
No, we are talking about attacking the AI employed by the drones.
Okay, so like an autopilot?
Like an autopilot, but probably a more sophisticated autopilot than those scripted ones currently being employed in UAVs. So current state of the art in commercial and military UAVs is hard-coded if-then statements. If this happens, then do this. They have to come up with algorithms and strategies to control the flow of information and the process happening in a UAV. In recent years, it's actually not that recent, but its employment in UAV is relatively recent. The trend in flight control has been towards machine learning. So let a UAV learn how to best control itself and how to best fly itself. One of the most interesting and popular approaches to machine learning for flight control is reinforcement learning. and deep reinforcement learning. I told you at the beginning that deep RL is the basis of the AlphaGo revolution. Everyone has heard that OpenAI and Google DeepMind have been working on the type of AI that can beat human players, the best human players, in highly complicated games, like the game of Go. Okay, now it's amazing. We have we have human level learning AI in the domain of games and somewhat in robotics and dynamics of robotic systems. How can we attack them? So I'm not going to go into the details of this because I don't want to talk about the basics of machine learning and reinforcement learning for the next half hour. If you're interested, I published a paper earlier this year with Arsalan, Professor Munir, on vulnerability of deep reinforcement learning to policy induction attacks. So using something called adversarial examples, which are intentionally perturbed inputs to machine learning or, well, let's, for the sake of argument, say neural networks. If you use adversarial examples, you can both manipulate the function that is learned by a UAV at test time and manipulate the policy that it learns or the function that it learns during training. You can, well, essentially manipulate the learner to learn to dive down whenever its altitude is above 10 meters and make it crash every time. Or one thing that we are going to work on pretty soon in the next week or so is injection of backdoors in the policy that's being learned. So backdoors are trigger mechanisms, like coming up, make it learn to do a specific thing after a sequence of events, predefined arbitrary events have happened. This type of attacks do not have any countermeasures as of now.
But how can we tamper with the training mechanism?
By providing your own training data with a directional antenna.
The learning
Well,
mechanism is not done during the operation.
that's true, but it's done during training.
Access before
If you have access to the training environment, or if you have an agent that continuously learns, even after its incubation period, its, well, air gap training period, if it keeps training itself during operation, that's how reinforcement learning works. It interacts with the environment based on its current state of training. If it keeps learning in the operation environment, you can manipulate it, or if you have access to the environment used for training, you can still manipulate it.
So it's more of an insider threat or a big antenna sitting outside the facility pointing at it?
Yeah, because you know who has access to the training environment. Everyone outside with a big antenna. So not a very strong adversary.
I disagree. I really want to go into the details of this, but I have a few more slides to cover and we're already 15 minutes over time. If you're interested in this topic, you can stay after the talk, and I really, really like talking about my own papers, so do come and talk to me. And this specific image here is pretty self-explanatory. So let's assume that we have a self-driving vehicle who's trained not to ever cross a solid line. What's this specific car going to do in this particular situation? Sit there. Yeah, that's how easy it is to manipulate, in the words of Dan Dennett, GoFi, or good old-fashioned AI. Now let's talk about anti-drone technologies. Why do we need anti-drone technologies? We just talked about the security challenges in a UAV system, and we know that UAVs are being applied in many useful application areas, but they are also being used for malicious purposes. For example, they're being used to smuggle contraband into prisons. This is actually a very, very sophisticated and high-profile problem in England. In the UK, I was consulting with for a company back when I was in the UK, whose whole intention and existence depended on coming up with a solution to prevent drones from trespassing into prison areas. Can anyone guess what sort of solution they came up with in the end?
A giant net.
Exactly. Yes. So they're using a giant net. How can we bypass this preventive measure?
Cut a hole in it.
Smaller drones.
Well, smaller contraband would also be required.
Exactly. So, yeah, you may have to smuggle in an assembly manual or something like that for the inmates as well.
Cut a lot up into 4 pieces and then
Yeah. All right. Well, that's an effective solution that's actually being employed here in the U.S. as well. I know that's in Ohio somewhere. They actually use this, or in the West Coast, I know that it's being employed in high security prisons, but probably for different reasons. Now, drones are being used for drug trafficking across the border. So after the submarine was captured from one of the cartels down in Mexico, they found a cheaper solution. It's DJI Phantoms and AR drones and such that go over the fence in San Diego or Juarez or places like that. And more often than not, they are not detected. Espionage. Well, we talked about ISR applications of drones, so they can be used for espionage both on a nation-state level or on an amateurish private level. If you want to kind of stalk your ex or see what your neighbor is up to, you can use a DJI Phantom for that. Easily, you don't have to manipulate it at all or modify it. Disruption. Well, drones, even their good intention uses, can be disruptive in many operations. For example, firefighting aerial operations are usually halted when a drone is detected in the vicinity. This was in particular a problem during the recent wildfires in Northern California. Flying drones around airports, hey, we don't want to kill passengers by crashing into a cockpit, do we? Flying drones in restricted areas, restricted aerospace. I believe it was a low-level, I think it was Geospatial Intelligence Agency. It was a GIA employee who, during a holiday, flew his DJI Phantom into the White House, well, its lawn. And back then, back in 2014, they didn't have any defensive measure against drones flying into the environment. And of course, terrorist attacks. ISIS has been using commercial drones to carry out aerial bombing attacks. They removed the main, for example, they removed the main camera under the belly of a DJI Phantom, replaced it with a grenade or something, and then flew it overhead of the Iraqi army or other militaries around. And they've used this type of attack extensively. Or they did use this kind of attack extensively. They are essentially non-existent as of last week as a territorial power. All right, so what are the solutions? Let's look at the Israeli solution. This is from 11th of November 2017. The IDF, Israeli Defense Force, fired a $6 million Patriot missile to shoot down a $100 drone. Can anyone see how ridiculous it is?
That's money well spent.
I believe that's an economic denial of service attack.
Yes. And this isn't the first time that IDF has used Patriot missiles to shoot down cheap drones. Last year when this happened, the use of Patriot missiles against, well, Light or simple DJI drones became an industry joke. So everyone and anyone in the defense sector, when they want to shoot down an expensive solution to a simple problem, they just say, hey, we don't want to shoot down a drone with a Patriot missile, do we? Yeah.
So, could you not manufacture a cheaper missile that might kinetic kill
Yes, you can.
rather than a explosive?
But think of the just cost of the guidance to get to guide something to a target this big. That's the hardware just to guide the thing.
Using a low-power laser.
So there are companies who are looking into that sort of solutions, but you'll see that you don't really need kinetic solutions.
So what if you split their stuff?
Yes, exactly. That's the kind of solution that I lobby for. Anyways, the American solution, zap them all with a laser. So in collaboration with Boeing and Lockheed Martin, I believe, this $15 billion project was finally unveiled this summer. It's a laser that zaps drones. It's cool. It's really cool and really expensive.
How much, so you said the price of this project, how much per unit?
I think it's $1 billion, but I'm not sure. Don't quote me on it.
But then also the cost per drone taken down is low after that.
It's not really that low.
Repairs and maintenance and
This is true.
the electricity costs are low, but every other cost is high.
Yeah.
Also, look how much space it takes up.
It's the French way. So I was actually in a meeting with the CEO of a company who wanted to hire me for consultation on anti-drone technologies. And at the same time, we opened a defense news agency's website, and the headline was this: France is training eagles to kill drones. Needless to say, I didn't get that contract. Other solutions, the traditional way. This cool-looking gun is actually a couple of directional antennas whose whole purpose is to jam the control signals of a UAV. Can anyone think of a problem or a way to kind of bypass this mitigation technique? Definitely. What else? So just so you know, jamming is not legal, in case you didn't know for some reason. Anyways, the problem is, how are you going to shoot down drones who do not use a command and control communication link? How are you going to stop autonomous drones? Yes, but you have to be very close for that to work. Or what if it doesn't use a sonar sensor?
The ultrasound actually, I think I read the same thing. It messes with the accelerometers and everything.
Yes. This is actually a solution that is developed by one of these anti-drone companies. It's already out there, but no one's buying it. I don't know. How close do they have to be for a sonar attack to work? I don't know. I don't have a number.
I mean, how much radiance can you cover with this?
Oh, I don't know. I don't remember the specs. But it's very similar to when you want to buy something off Walmart. You can go to their website and look at their specs. The range of the jamming attack depends on the transmission power that you want to use, and legally, the range is 0. Not for ultrasound. I don't know about ultrasound. I thought you were talking about radio jamming attacks.
No, sound frequencies are not licensed. Otherwise, I would be broke.
After the Cuban embassy incident, I think they may change the regulations over it. But right now, you're right. It's not regulated. The sensible way, my way, which I've been lobbying for and I've been proposing to anti-drone startups and other defense companies working on anti-drone technologies, is to go with a completely cyber and electronic countermeasure solution. Software-defined radios plus active and passive radars. Software-defined radios give you flexibility to kind of adapt to all kinds or many kinds of UAV links and communications and such. You can define a cycle very similar to a cyber attack cycle, enumerate, fingerprint, exploit the type of cyber physical vulnerabilities that we went over during the course of this presentation, and rinse and repeat. Next year or so, a few of the companies that I've been associated with are going to roll out fully automated cyber physical anti-drone solutions which do not use any kinetic force at all. Unfortunately, I can't disclose more details. That's the power of NDAs over my head. But the bill of materials cost, the cost of one unit, manufacturing one unit, put R&D aside, is going to be less than $1,000. All righty. Does anyone have any questions? Yes?
What was wrong with the data analysis and the anonymity of the
I think they did not consider a number of priors, like a number of a priori information or assumptions that can be made